The year was 1947. The world was still grappling with the aftermath of World War II. Cities were being rebuilt, lives were being mended, and nations were striving to regain a sense of normalcy. Yet a new challenge was on the horizon. This time, it wasn't a conflict between nations or ideologies. This time, the adversary was nature itself. Unpredictable and often destructive, nature posed a new kind of threat. Scientists were ready to confront a hurricane's wrath, driven by a bold vision and an insatiable quest for knowledge. They believed they could control the uncontrollable. With careful planning and unwavering resolve, they embarked on a mission many thought impossible. Could they really tame these powerful storms? The question hung in the air, filled with both hope and doubt. Their target was Hurricane King, a formidable storm that had already demonstrated its power. It churned ominously in the Atlantic. The swirling mass of clouds and wind was both mesmerizing and terrifying. It threatened to unleash its fury on the southeastern United States. Communities braced for impact, aware of the potential devastation. A team of scientists watched intently. They had spent countless hours preparing for this moment, their eyes fixed on the instruments guiding their actions. They were armed with an innovative tool, dry ice. This simple substance, if used correctly, could potentially alter the storm's path. Their mission was ambitious, even audacious. They aimed to weaken the hurricane, steer it away from populated areas, and save countless lives. They were determined to change the hurricane's course. The stakes were high and the pressure immense. The fate of countless lives hung in the balance. As the storm approached, the world watched and waited, hoping that science could triumph over nature's fury. Hurricanes originate from the combination of warm ocean waters and moist air. This combination creates a powerful swirling vortex. Hurricane King followed this same pattern. It formed in the tropical regions off the coast of Africa. It intensified as it traveled westward. The storm grew in size, with its winds becoming increasingly fierce. Meteorologists monitored King's progress closely. They relied on basic forecasting instruments. The projected path of the storm was alarming. It was expected to hit the densely populated eastern seaboard. The potential for severe damage was significant. The scientific community felt a pressing need to respond. They needed to act swiftly. Project Cirrus emerged from a unique collaboration between the U.S. government and General Electric. This pioneering effort united top experts in meteorology, engineering, and military strategy. It was a highly classified mission, cloaked in secrecy and intrigue. The stakes were immense, as the project aimed to confront one of nature's most powerful forces. The objective was to investigate the possibility of modifying hurricanes. This was a bold and unprecedented goal, one that could revolutionize meteorological science. The scientists had a hypothesis. They believed that by intervening in a hurricane's natural processes, they could alter its path or intensity. They theorized that seeding a hurricane with dry ice could disrupt its internal structure and potentially weaken it. This idea was based on the principle that introducing a foreign substance could cause the storm to lose its cohesion. The concept was groundbreaking. If successful, it could lead to future weather control techniques, potentially saving countless lives and preventing massive property damage. A modified B-17 bomber became their vessel into the storm. This aircraft was specially outfitted to handle the unique challenges of the mission. On October 13, 1947, the plane took off from a base in Florida. This date marked a significant milestone in the history of meteorological research. It carried a payload of 180 pounds of dry ice. This was a carefully calculated amount, intended to maximize the chances of disrupting the hurricane's structure. The crew was ready for a perilous mission. They had undergone extensive training and were fully aware of the risks involved. They were about to fly into the heart of one of nature's most powerful forces. The storm was a formidable adversary, and the outcome was far from certain. The world held its breath. As the plane disappeared into the swirling clouds, everyone involved knew they were witnessing a moment of potential scientific breakthrough. The B-17 rumbled towards Hurricane King. The aircraft trembled as it breached the storm's outer bands. Rain pounded against the cockpit windows. The turbulence rocked the plane violently. The crew, secured in their seats, endured the hurricane's full force. They pressed forward, eyes locked on the swirling vortex ahead. They identified a prime target within the hurricane's eye wall. The dry ice was deployed into the storm. The crew watched the effects with a mix of excitement and apprehension. The hurricane, seemingly provoked, began to respond. This was a critical moment. They had tampered with nature on an unprecedented scale. The outcomes were unknown. Chapter 5. Seeds of a Scientific Revolution. The concept of cloud seeding wasn't a novel idea. It originated from the General Electric laboratories in the 1940s. Vincent Schaefer, a chemist at GE, stumbled upon the cloud seeding principle by chance. He discovered that dry ice could trigger the formation of ice crystals in supercooled clouds. This finding had profound implications for weather modification. If dry ice could generate clouds, could it also alter existing weather patterns? Project Cirrus aimed to explore this question. It sought to apply this knowledge to a much larger and more powerful weather system, a hurricane. Chapter 6. The Hurricane's Unexpected Turn. After the dry ice seeding, Hurricane King experienced a significant change. It suddenly deviated from its expected trajectory. Rather than continuing westward, it unexpectedly turned north. The hurricane struck the coastlines of Georgia and South Carolina. This led to extensive damage and flooding. The public's reaction was swift and severe. Project Cirrus, once seen as a groundbreaking effort, was now criticized for the hurricane's unexpected turn. The scientific community found itself embroiled in controversy. Did they unintentionally direct the hurricane towards land? The evidence was not definitive, but the doubts remained. Section 7. A Legacy of Innovation and Uncertainty. Project Cirrus, despite its contentious results, marked a pivotal moment in our understanding of weather modification. It showcased the potential, albeit unpredictable, to alter hurricane behavior. It also underscored the ethical dilemmas of manipulating natural phenomena. The legacy of Project Cirrus continues to influence the field of meteorology today. Although we have made significant advancements in hurricane forecasting, the aspiration to control these powerful storms remains out of reach. Researchers persist in exploring ways to lessen the devastating impacts of hurricanes, now with a heightened awareness of the potential risks and ethical considerations. Chapter 8. The Ethical Storm Rages On. The ethical debate ignited by Project Cirrus is still very much alive today. This initiative, which sought to control the weather by seeding clouds to change precipitation patterns, opened a Pandora's box of ethical dilemmas that we continue to wrestle with. The ramifications of such power are extensive and intricate, touching on environmental, social, and moral dimensions. As we advance in developing more sophisticated technologies to manipulate the environment, we must carefully weigh the potential consequences of our actions. The ability to control weather patterns could help mitigate natural disasters, but it could also be weaponized or lead to unintended ecological consequences. The balance between innovation and caution is delicate and must be navigated with care. The atmosphere is a fragile and interconnected system. Every action we take to alter it can trigger a chain reaction of events that are difficult to predict. The complexity of atmospheric dynamics means that even small changes can have significant impacts, potentially disrupting weather patterns and ecosystems far from the original point of intervention. Tampering with one part of the system can have unforeseen and far-reaching effects. For instance, altering rainfall in one region could lead to droughts in another, affecting agriculture, water supply, and biodiversity. The ripple effects of such interventions could be profound, highlighting the need for a thorough understanding of the potential risks and benefits. The question is not whether we can control the weather, but whether we should. This ethical dilemma forces us to consider the long-term consequences of our actions and the moral responsibility we have to future generations. Should we prioritize short-term gains or take a more cautious approach that considers the broader implications? Should we, as a species, have the power to alter natural processes that have shaped our planet for millennia? The natural world has evolved over billions of years, developing intricate systems and balances that sustain life. Interfering with these processes could have unintended consequences that we may not fully understand until it is too late. Or should we respect the delicate balance of nature and focus on adapting to its rhythms? Instead of trying to control the environment, we could invest in sustainable practices that work with natural systems rather than against them. This approach emphasizes resilience and harmony, promoting a more sustainable and ethical relationship with our planet. These are the ethical questions that continue to swirl around the legacy of Project Cirrus, urging us to proceed with caution and humility in our quest to understand and manage the forces of nature. As we move forward, it is crucial to engage in open and inclusive discussions that consider diverse perspectives and values. Only by doing so can we hope to navigate the ethical storm and make informed decisions that benefit both humanity and the environment.